Well, thanks for having me. My name is Paul Mayencourt. I'm a professor of cooperative extension between Department of Architecture and Department of Environmental Science, Policy and Management. I'm a structural engineer and I co-run the Berkeley Woodlab. So if you've been in California long enough, I'm sure you've seen these kind of pictures, but also like smell the air sometimes. We have a big wildfire problem. Um, Part of it is a lot of trees that are burning and we're not using for anything else. And the other part of it is this, there's a recent study showing that the emissions of these wildfires are actually responsible for a lot of carbon emissions. So if you believe the study here that was published about 3 years ago, 1 year of wildfires in 2020 has negated all carbon emission reductions of the last 10 years. And that's a lot of carbon. And that's, every one of us here in the room trying to decarbonize the built environment. We're not only talking about the built environment, but also every sectors where we try to reduce carbon emissions. So a big problem that we should address in California. And one of the solutions people talk about is using these trees for mass timber. So this is an example of a mass timber building. If you walk down the path right there, this is the new mass timber building on campus that is about to be finished. And one of the issues maybe with this building is if you look at where the wood is coming from, it's been harvested and produced in Quebec, Canada. So we made all these elements that you see on the picture, shipped them from the other side of the continent, and then build it here. So, it is a bit of a missed opportunity that we have all these trees burning, and at the same time, we're importing entire buildings from a different country. It's easy to say that we can build local houses or local buildings with local trees. It's a bit more challenging when you want to actually implement it in California. The kind of trees we need to take out of the forest to kind of support forest restoration and reducing the risk of wildfires are smaller trees that don't really pay themselves out of the forest. They don't really compete with bigger trees that we have in California for sawmills, so they're not really attractive. And another thing is we have nobody making any wood products or mass timber in California. At the moment, that was true maybe 2 months ago, and this is slowly changing. So part of the research that we have at the Berkeley Woodlab is how do we create a new mass timber industry in the state of California that adds value to low-value feedstock, like the small diameter trees and species that we don't really know how to use. And then how do we create this industry so that it's even lower carbon than the current state of the art? So I said I co-run this new lab that we started about 2 years ago. We run it out of the Berkeley Richmond Field Station. I don't know if you've been there, but we have a couple of buildings where we have a sawmill, some kilns, and a large fabrication space where we test some prototypes in mass timber. And one of the focus we have is mass timber. We want it to be lower carbon, so even lower carbon than the current state of the art. But we also want it made in California. If you look at the typical process of taking trees and making buildings, if you worked on mass timber buildings, you probably know this, but you go to the forest, cut a tree, take the logs, make some boards, dimensional lumber, and that process of milling round trees into dimensional lumber that is squared has about 50% of waste. So we've kind of developed an industry around a process that has generally 50% of waste. So we just turn a lot of trees into sawdust. And the trees that we want to get, they're not really, the trees that we should get to support the health of the forest. They're the trees that make the most money. So I'll show some of the work that we're doing in small diameter tree veneers and how we think that could be applied for California forests. Once you have these boards, you want to dry them to be part of a building. Wood is full of water when it's cut. So to be in a building in equilibrium with the air, you have to dry it before using it. The process of drying wood to use in buildings uses 75 to 90% of the embodied energy that we put into creating wood products. And it's convenient because we have a lot of sawdust that we can burn, but maybe we can do a little better. So I'll show some work that we've been doing with CBE on solar kilns and how we think that we could probably reduce this impact of wood products. Once you have dried and cut board, you typically glue them into what we call engineered wood products, CLT or glue lamps. And with new discussions around circularity and glues are becoming kind of a question mark in the production of wood products, is like, can we do something a bit differently instead of gluing all these boards together and then make it really hard to recycle or reuse in the future? And at the same time, there's also VOCs coming from these glues. So I'll share some of the work that we're doing in NLT and DLT, so different types of wood products that we're trying to push in California. Once you have these products, they go into a building, they're packed, and then I mentioned we have a global supply chain for these wood products. So Quebec is giving us entire buildings that we build on campus. So how do we kickstart an industry here in California in a way that's working financially, but also is competitive at the global supply chain. So I'll show some of the work that we call DIY mass timber, how to get started in the industry. So you've seen this picture before, small diameter trees from California. This is the challenge. One technology that we're really excited about is peeling these trees into veneers because we can recover more of the resources from them. But we also found this new technology of veneer lathe that is coming from Southeast Asia that is actually able to access small diameter trees as a resource. So peeling trees is kind of putting the log into a big pencil sharpener, and then you get a thin sheet of veneer that you can re-glue together into plywood that we know, mass plywood panel that is made in Oregon, for example, or any types of veneer products that can be used in industry like LVL. And then at the end, you have only this much left over. So you have a high recovery efficiency from these small diameter logs. This is a picture of the lathe line that we just received at the Berkeley Woodlab that we're currently in the process of installing. It's taking us a bit of time, but this is back in March when we first had it delivered. And then we'll have it kind of run by the end of the year, hopefully. And one of the ideas is that we can recover more resources from smaller trees that are previously not accessible as a resource because they don't really make sense to use in bigger mills where they want to make 2x4s. But we also can create products that are higher in efficiency because we can mold them into higher kind of an I-beam-like structure that we don't really have in mass timber. This is an example from Germany, wood flow, where they kind of make corrugated metal versions of wood. So we're interested in kind of pushing in that direction. I mentioned up to 90% of the embodied energy in wood products is coming from the drying process. So we've kind of revived this older idea of solar kilns. It's very simple. It's a greenhouse. Instead of putting it to a large building that we heat with burning wood, we just let it dry outside in a greenhouse. So this is the solar kiln that we built at the Berkeley Woodlab after this paper that was published a while ago. And together with Paul Rafter and Jan Wang from CBE, we've kind of like pushed this to a bit further to understand the performance of these kilns. So with energy modeling, we've been able to kind of place computationally these kilns in different locations in California, use different materials, and predict the drying performance of these kilns for a variety of climates, time of the year, and also construction types. So here on the right, you can see a picture of the drying rates for different types of woods, different starting contents of moisture, and how long it was going to take. So someone can take this graph and estimate, is it worth it for me to build a solar kiln in this area? We've built a couple more, and then the one at the Berkeley Woodlab. This is a solar kiln that we built at Forestry Collective in Sebastopol using small diameter trees or tree tops to make panels and make the walls of the kiln. And then this is another kiln that we built in Santa Cruz on the mountains with a different sawmill that we work with. And this time it's a half geodesic dome to kind of explore the balance between material and geometry for these different designs. I mentioned we're working on different types of wood products that have less glue. So NLT or DLT, nail laminated timber or dowel laminated timber. You take boards and you stack them together, push a dowel through it, and then you have a DLT panel. If you nail it together, you have an NLT panel. Nothing new. The buildings that we have at the Richmond Field Station, built in the 1950s, have been built with the system 80 years ago. They are in the codes. If you look at the California Building Code, you have a 2-page list on how to nail these together so they are accepted and they can go into a building. So anyone here could actually go to Home Depot tonight, build a nail gun, and start making these panels and use them in buildings. But it's kind of been forgotten because they were less kind of shiny as other products like CLT. So here's an example of a very standard building that you can do with DLT or NLT. This is from StructureCraft. They're based in Canada. They've been producing NLT and DLT for the last 10, 15 years. One aspect I mentioned is reuse. It's like if we don't use glue, can we reuse this product many times? And we asked this question and we actually did it. So we nailed and denailed NLT panels about 10 times. And every time we denailed them, we tested how strong it still is after the denailing process. So we collaborated with Urban Machine, a company that used to be in Oakland, and they kind of fabricated this denailing robots that can go heat the nail and then pick it and remove it. And you can see on this picture, for example, the bottom left, where we've denailed the board 10 times. And every time we tested to see how much stiffness we were losing by the process of removing the nail, creating a hole, and kind of breaking the fiber. So after 10 cycles of reuse, we have about 1% of decrease in bending stiffness. That means that we can actually recycle these pieces of wood 10 times in different life cycles of building and have almost no change in the bending performance, the main use case of these panels. So we're about to publish these results, hopefully in a couple of months. But you can see here that if you have a building that is using these systems for about 50 to 100 years, and they reach 10 times, you have about like a 500 to 1,000 year carbon storage capability using these systems. And the last project I want to show is what we call DIY mass timber. How do we get started in California to have this product made here instead of delivered from very far away? And part of it was because we were frustrated in the shop waiting for this lathe machine to come. We started making panels. So we also made drawings to explain to people how they make these panels very simply. So this is an example for NLT. You only need the nail gun, a bunch of lumber, and a couple of nails, and then you can actually make panels that you could use in a building because they follow the building code. And we've been going around California for the last 2 years, showing people how to make both NLT and DLT. So you can see here the sets of tools that you need to make a panel out of DLT. This is not the most efficient production method, but as a way to get started and understand how it works, it's been actually really effective. So from this kind of like initial DIY versions, there's a couple of groups that started making these panels. So at the top, you see Forestry Collective with a student from UC Berkeley making a small NLT panel from tree tops for the solar kiln I was just showing. And then Mad River Mass Timber, a larger version of DLT that they made last year. And now they became a company making panels in Humboldt. And then at the bottom right, a collaboration with Urban Machine and Old Bay Lumber, where we kind of created a small scale machine to make DLT at small scale. So it's like the size of a car. You can bring it everywhere on a trailer, and you can make DLT in different locations. So this is what I have for today. Come for a tour at the Berkeley Woodlab. We have a lot of things to show. One thing I would like to kind of ask for everyone, if you have any mass timber projects, is try to support the emerging kind of manufacturers we have in California. I mentioned Mad River Mass Timber now, the way they make DLT. Hopefully, we'll have a couple more in a couple of years. And if you have any questions on your help you need on some mass timber projects, I'm here for this, and I'm happy to help. I also run a roundtable discussion later this afternoon on these topics. So if you want to have a bit longer chat later, please come and join us. Thank you.